B.Tech Electrochemistry, Module 6.8, Corrosion. In the Module 6.7, and we have discussed the concept of pH, measurement of pH, using various types of electrodes including glass electrode, and how we can calculate the pH during the potentiometric titrations of the strong acid, strong base, weak acid, strong base, and weak base, strong acid. Now, in the next, the module, the 6.8, we are going to discuss about the important topic in the electrochemistry, corrosion. It is corrosion of metals. In the materialistic world what we are living, most of the materials or equipments are made up of metals. These equipment have to be utilized for a long time, for which the metallic parts of the equipment have to be protected for a long time, for which why metal cannot be protected, why metal will undergo the corrosion, it is a decay, and how to protect the metal from the corrosion. So there are all the various technological aspects in the electrochemical science and technology. Now let us understand the word corrosion. Corrosion means decay or disintegration or deterioration. Now corrosion of metal means the decay or deterioration or disintegration of the metal with the environment, or this environment may consist of the corrosive medium. So under these conditions metal undergo corrosion. Conversion of the metals, pure metals, into metallic compounds which are unstable is known as corrosion, the definition of corrosion. Conversion of a metal into metallic compounds means what compounds? No. We know very well in the metallurgy chapter, most of the metals are available in the earth crust as minerals or ores. Most of the minerals are metal compounds. They may be metal carbonates, metal oxides, metal chlorides, so on and so forth. Metals, when exposed to the atmosphere, the atmospheric oxygen or the carbon dioxide or hydrogen sulfide and react with the metal and convert the metal into metal oxide, metal carbonate, metal sulfide, so on and so forth. Almost all the metallic equipment and uses iron as a main material. So iron easily undergoes corrosion and rust formation occurs. The formation of the rust on the iron is the best example of the corrosion. What is this? The product formed in the corrosion of iron. The product is Fe3O4, magnetic oxide of iron, rust. Further we defined this product should be a unstable material. Unstable means you should not stick to firmly to the surface of the metal. We know very well the rust present on the iron can be easily removed either by scratching or by tampering. But whereas some of the metals react with the oxygen, they form metal oxides which are very, very stable. For example, the oxides of some transition metals, titanium, zirconium, hafnium, niobium, once they are oxidized, the oxide films are formed. Those oxide films are impervious to the environment. Hence, the metal will be protected. But however, most of the metals, they form unstable products. Now, the corrosion of metal can occur by two mechanisms. One is electrochemical mechanism, another is chemical mechanism. Electrochemical mechanism means electrochemical cell formation, anode, cathode, electrolyte. Anode undergoes oxidation. The oxidation of anode is corrosion. This is called electrochemical corrosion. But whereas chemical corrosion means the reaction of the metal directly with the chemical substance present in the atmosphere or in the environment. Therefore, here the two factors are mainly responsible to affect the corrosion, which are, one is nature of the metal, another is nature of the environment. Conversion of the metal into metal compound is called corrosion. Whereas in the metallurgy process, metal compounds are converted to metal, is called metallurgy. However, the metals which are prepared from the metal compounds, again they are highly reactive. There is a possibility of the corrosion. Therefore, there is a need to protect the metal from the corrosion. Factors affecting the corrosion. One is nature of the metal. The second one is nature of the environment. Now, we will discuss in detail how nature of the metal affect the corrosion process. Nature of metal. Position of metal in the galvanic series. In the galvanic series. We will discuss in detail what knows here. Galvanic series means electrochemical series. In one of the module, we have studied this electrochemical series. Based on the standard reduction potentials data, the metals are arranged in a serial order, in a series. That is called electrochemical series. More active metals are arranged at the top, less active metals are arranged at the bottom. Therefore, once the series is observed, and we will have a knowledge which metal undergoes corrosion fast. This here is known. So therefore, higher the place of the metal in the electrochemical series, higher the rate of corrosion. So here the important is the find is now higher the place, higher the rate of corrosion. Suppose if you consider the zinc and the copper, zinc oxidation potential E0 0.76 volts, whereas copper oxidation potential is 0 minus 0.34 volts. It indicates zinc is highly corroding metal compared to the copper. The second one is small area or areas. We know very well certain areas of the metal undergo more corrosion compared to the other areas. What type of areas undergo more corrosion? There is no. And here is smaller area parts of the metal undergo corrosion fast. For example, a metal is having corners. These are called corners. The surface area of a corner is much less compared to the other parts. Or bend the metal rod. The part at which the bend is observed, you have a less area compared to the other parts. So these are the parts at which the more rate of corrosion occurs. Next. Third one is higher solubility of products. Solubility of products. The corrosion gives corrosion products. If the corrosion products are more soluble in the environment, then rate of corrosion will be more. Solubility of products. More the solubility, more the corrosion. Another point is high over voltage. Over voltage eta defined as the potential which is applied minus equilibrium potential 50. The excess potential applied over the equilibrium potential so as to observe some net current is known as over voltage or over potential. So over potential values for the hydrogen evolution, oxygen evolution, then you can have. So therefore, the higher the over voltage, higher the rate of the corrosion. Here is now. That means as over voltage is more, corrosion rate is more. Next one is more volatile nature of products. More volatile nature or volatile nature of products is another factor affecting this one. Now, some of the products which are the formed, they are highly volatile. For example, molybdenum oxide or SnCl4. Now, the products are more volatile means again the fresh base metal surface is obtained. That base metal again starts undergoing corrosion. Next one is unstable surface film that we already have studied. Whenever the compound which is formed is unstable, it will have a porous nature. Hence, the environment, the corrosive environment may penetrate through this porous material and make the metal to be more and more corrosive, the inner parts. That means the extent of the metal which undergoes corrosion will be more, and if the corrosion products are unstable and porous nature. Next, lower specific volume. Here is no. Lower specific volume means volume of the metal oxide and volume of the metal. if this ratio is calculated, this ratio is inversely proportional to the rate of the corrosion. Hence, the lower the specific volume and the lower the rate of, the higher the rate of corrosion. So here is now lower specific volume. Lower specific volume. So lower the specific volume, higher the rate of corrosion. Next, consider a pure metal. Consider impure metal. Compared to the pure metal, the rate of corrosion of impure metal is the more. So corrosion rate increases as the purity of the metal decreases. Here is now. Now we will come discuss the nature of environment. Environment means the surroundings of the base metal or the corroding metal. One of the environment is temperature. As temperature increases, the corrosion rate increases. We know very well in the chemical kinetics, the rate of a process depends on exponentially on temperature. Therefore, corrosion plays the dominant role. Next, higher humidity. That means amount of the water vapor content in the atmosphere. As humidity increases, corrosion rate increases. And the third point is pH. We know very well 0 to 7 is acidic range, 7 is neutral range, 7 to 14 is basic range. Metals undergo corrosion easily in acidic environment and rather than basic environment. So therefore, and as pH decreases, it is acidic range, corrosion rate increases. Next one is conductance of the medium. Conductance of the medium. We know very well the salt solution is having higher conductance compared to the non-electrolyte, the solution. So the solution which is having highly conducting nature or the medium which is having high conductance, here no. As conductance of the medium increases, the corrosion rate increases. Another point is oxygen content. Oxygen, O2 content. Most of the corrosion products are oxides of the metal oxides. So oxygen is the main corrosive environment. So higher the content of the oxygen in the environment, higher the rate of corrosion. So as oxygen content increases, the corrosion rate increases. Next one is strong oxidizing agents. Oxidizing agents. Conversion of the metal into metal ion is the first step in the corrosion mechanism. Therefore, oxidizing agents and always remove the electrons from the metal and make the metal to be more corroding. As the oxidizing nature is more, the corrosive nature as the corrosion rate also increases. Thermodynamics of corrosion. Suppose consider a cell reaction, oxidation reaction. M gives Mn plus n electrons. For this, the electrode reaction, find out what is the E0 value. Suppose E0 is more positive. Delta G is equal to G0 is minus N of E0. E0 is more positive means delta G0 is more negative. Therefore, more spontaneous. Hence, this thermodynamic data or the EMF data of the electrode reactions, they helps to understand the corrosion rate. Now let us consider some of the reactions in the corrosion process. One is, unless there is a agent which will remove the electrons from the metal will not undergo corrosion. Therefore, what are the reactions which are responsible and which helps for the corrosion process? H++ electron gives half H2. Here is E0, 0. Whereas H++ 1/4 O2 electron gives half H2O, for which E will be 1.23 volts. Whereas consider, these are all acidic medium. In the acidic medium, the possible reactions are, here is no de-electronation reactions. These are electronation reactions. In alkaline medium, in acidic medium, in alkaline medium, the reaction responsible for the removal of electron from the metal is 1/2 H2O, 1/4 O2, as electron gives OH minus. E is equal to 0.40 volts. These potentials are greater than the potential for the process E0 Fe2 plus use Fe. As these reactions are responsible for the corrosion of the iron. Why gold is not corroding at all? The main reason is its potential. E0 Au3 plus gives Au. The potential is 1.5 volts. Hence, the gold is not corroded in any environment. No. How the corrosion process is occurring? What process is responsible for the corrosion of a metal? For which we have to understand the theories of corrosion. There are two theories of corrosion. One is wet theory or electrochemical theory. Second one is dry theory or chemical theory. That means corrosion can occur by electrochemical mechanism or by chemical mechanism. So electrochemical mechanism corrosion is called the wet corrosion, whereas the chemical corrosion is called dry corrosion. This is the one we know. So let us have a little bit more understanding regarding the each and every theory. Here is now. Wet theory of electrochemical corrosion. Here is now. In the wet theory, dissimilar metals are different natured parts of the metal is the main part. Dissimilar metals means now you take the two metals. Suppose a metal is impure. So impure metal and the main metal. Out of these two, one will act as anode, one will act as a cathode, depending upon the electrode potentials or their places in the electrochemical series. So whenever the dissimilar the metals are immersed in a wet environment, so the electrochemical reactions occur. At the anode, oxidation occurs, whereas at the cathode, the reduction occurs. This electrochemical oxidation and electrochemical reductions, they are occurring at the different parts of the material and responsible. Already we have seen different nature, the parts of the metal. Though metal is same, but depending upon the stress and strain and at the different parts, one part may act as a anode relative to the another part. We have seen whenever a metal is bent, the part where there is a bend and it acts as a more corrosive, that is the anodic part, remaining part of the metal acts as cathodic part. Here is now. Here is. In the wet corrosion process, here is the rate at which the metal corrode depends upon the difference in the potentials of the two. Here is now. So E0 2 minus E0 1. So the higher the difference in the oxidation potentials or reduction potentials between the two dissimilar metals, the higher the rate of corrosion is known. Now in the wet corrosion, generally the reactions, the wet corrosion, the electrochemical reactions, here is anodic reaction is already known, which is metal gives metal ions, whereas cathodic reaction in most of the process now, the hydrogen evolution reaction, 2H plus 2 electrons gives H2. So these reactions are responsible. However, these electronation reactions can be of the different we have seen. Other possible reactions, the cathodic reactions which are possible are O2 plus 4H plus 4 electrons gives 2H2, or O2 plus 2H2O plus 4 electrons gives 4OH minus. So any one of the cathodic reaction helps the corrosion of the metal. Then in the dry corrosion, you will not have the two metals, combination of the two metals, dissimilar metals, or the different, the natured parts of the metal, but here the environment is responsible now. So here is a dry corrosion, mainly a reaction between metal and gases. You know very well, metal, if reacts to oxygen, MO2 is a corrosive product, or M plus Cl2 gives MCl2, or M plus H2S may give MS plus H2, metal sulfide. In the same metal carbonate also can form. This dry corrosion mainly occurs when no appreciable flow of current through the metal. There is no. but whereas in the wet corrosion, appreciable amount of current flows through the metal, hence electrochemical reaction occurs. Here is now. Now, in the environment, the atmosphere may contain the gases such as oxygen, carbon dioxide, sulfur dioxide, chlorine, H2S, F2, etc. Here is now. Next, in the dry corrosion, whatever the products which are formed, and they may be volatile, or they may be non-porous materials, or they may be porous materials. Therefore, the nature of the compound which is formed decides the extent of corrosion or the rate of the corrosion. Here is now. There is another called liquid metal corrosion. Instead of a solid metal, if a liquid metal which is flowing, that means a flowing liquid metal, and exhibits the more corrosion compared to the static metal. This. Lastly, we will discuss what is a comparison of the wet and dry corrosions. Comparison of theories of corrosion. Theories of corrosion. Here is electrochemical corrosion, chemical corrosion. Whatever we have said, just we are summarizing. Is now. Here conditions are wet conditions. Here is, and occurs in dry conditions. Dry conditions. Galvanic cells are formed, which is a necessary condition for the electrochemical corrosion. Whereas here, direct attack of metal with environment chemicals. And third one is, whenever galvanic cells are formed, electrochemical reactions occur. Whereas here, chemical reactions occur. Chemical reactions are responsible for the chemical corrosion. This is called heterogeneous corrosion. Whereas here, homogeneous, sometimes heterogeneous. Homogeneous or heterogeneous. In the case of electrochemical corrosion, non-uniform corrosion occurs because all the parts of the metal will not have the same extent of corrosion, non-uniform corrosion. Whereas here, uniform corrosion. Here is, the rate of corrosion is fast. Corrosion rate is fast. Whereas here, corrosion rate is slow. In this way, you can contrast the electrochemical corrosion and chemical corrosion.